Welcome to the 12th lecture in Riparian Function and Management. In our previous lesson, we began learning about the special characteristics of riparian management. We discussed the fact that riparian areas are small yet special and sensitive, yet resilient. Successful management of riparian areas for the production of value requires that we think water catchment, not watersheds. We can benefit from a perspective that looks back at past conditions as well as forward toward desired conditions. Their management has evolved with understanding to include the idea of cooperation along a shared resource. And as with other natural landscapes, a strong stewardship ethic is a prerequisite to successful sustainable management. In this lesson, we will apply that understanding as we learn more about the basis for riparian management. This lesson, we will discuss riparian management intensity, riparian function as the cornerstone, maintaining equilibrium, identifying, addressing, and removing hindrances, natural regeneration, and artificial revegetation. Riparian management comes in many different forms with no two situations alike. Differences between riparian areas, differences in landowner goals, and differences in resources available for management all combine to create infinite variability in riparian management. While the same general principles apply across multiple situations, the specific ways in which management is carried out will differ a great deal from place to place. Riparian management can be divided into three broad categories, each requiring different intensity of management. Some projects call for a combination of approaches, such as maintaining existing riparian conditions, improving or enhancing riparian conditions, and restoring degraded and non-functional riparian condition. The various intensities of management required for riparian areas also suggest a logical priority of management. Maintaining an intact riparian area is much easier and more economical than attempting to restore a non-functional, deteriorated area. Furthermore, the likelihood of success is much greater and the risk of failure is much lower. If resources are limited, funds invested in maintaining or enhancing riparian condition will go much further than intensive and expensive restoration projects. As with many other aspects of natural resource management, it is always better to prevent riparian problems rather than trying to repair the problems. However, this should not discourage intensive restoration projects if the resources are available. If you'll recall the definition of riparian function described earlier in this course, it is important to be able to differentiate between the values provided by riparian areas and the basic physical-mechanical processes that support these values. It is vital to understand that the physical processes are what generate and sustain the values that we desire. If riparian managers understand the importance of maintaining the physical, all else will follow. Contrarily, riparian management that is focused primarily on these human, biological, economic values without understanding the physical processes is likely to result in frustration, limited success, and false expectations of what is possible. Each of these components of riparian function involves physical processes which are governed by the universal natural laws of physics and energy. It should be emphasized that the physical functional processes take place in the context of adequate riparian vegetation, of landscape formation, think boulders, sinuosity, and channel roughness, as well as large woody material. The most successful riparian managers will have a good understanding of how all of these factors affect riparian function. In a natural setting and in the absence of significant artificial disturbances, most riparian areas will maintain themselves in a relatively stable condition known as dynamic equilibrium. According to this concept, creeks, rivers, and riparian areas react to normal disturbances in a manner that compensates and helps correct for the disturbance. In this way, creeks and rivers utilize these disturbances for their own benefit and are always at work to fix themselves. This concept of equilibrium should not be misunderstood. It does not mean a perfectly stable balance, nor does it mean the absence of disturbances, nor does it mean additional man-made disturbances don't matter. Riparian areas are naturally prone to significant and even extreme disturbances. These natural disturbances include both erosion and the deposition of eroded material both spatially and temporally. The intensity, duration, and frequency of flooding and/or drought are the most common disturbances that temporarily upset the equilibrium. Other natural disturbances that may temporarily upset equilibrium include washing out of beaver dams, insect or disease problems that disrupt key riparian vegetation, wildfire, and natural grazing and browsing by wildlife. These natural disturbances often cause lateral migration of banks, formation of new gravel and sand bars, and the subsequent changes in sinuosity and channel gradient. These changes are countered by the eventual stabilization of new surfaces by riparian vegetation. When various activities cause severe and prolonged disturbances, the creek or river attempts to accommodate the disruption with an equally severe reaction, thus upsetting the normal equilibrium. Most of the chronic riparian problems seen in Texas are the result of these excessive or abnormal disturbances that repeatedly disrupt the equilibrium and keep the creek or the river out of balance. Extreme and recurring bank erosion, channel downcutting, excessive deposition of sediment and aggradation of channels are common indicators that creek and river systems may be out of balance and are attempting to reestablish a new equilibrium. Disturbance with heavy equipment along the banks for floodplains will often result in large additions of sediment to the channel. This will greatly disrupt the balance. A basic understanding of these dynamics will greatly enhance a manager's ability to recognize what is happening in the riparian area. Often, a perceived problem is merely the creek making necessary adjustments to rebalance equilibrium. Managers who do not understand the natural seesaw process of imbalance and rebalance are often attempting to fix something that does not need to be fixed. The unnecessary fixing of some problems actually impedes the normal and natural process of equilibrium and can be very expensive. The basic principles of dynamic equilibrium are illustrated by the Lane balance seen here. In previous lectures, we discussed Emery Lane, who was a hydrologist with the Bureau of Reclamation and who first described the four basic variables of equilibrium: discharge of water, sediment load, slope of channel, and size of sediment. The Lane balance does not consider the energy dissipating and stabilizing capability of vegetation. Vegetation serves to buffer dramatic swings in the water and sediment equilibrium. Vegetation is often the only component that is within our ability to manage. Riparian managers do not need to become expert hydrologists or fluvial geomorphologists. However, if managers understand how the balance works in theory, they can learn to predict responses to disturbances and will be able to see how creeks and rivers make adjustments to restore the balance. Riparian workers have discovered a fundamental truth that helps to deal with most out-of-balance riparian conditions. If one or more activities or issues can be identified that are hindering the normal equilibrium dynamics, and if those disrupting activities can be corrected, then in most cases the riparian area will begin to mend itself. Stated more simply, stop doing those things that appear to hamper the natural rebuilding process, and the riparian area will tend to restore itself. It is not so much a matter of knowing precisely how to fix a degraded riparian area, but rather allowing natural processes to work unimpeded. In most cases where there are chronic or acute riparian problems, one or more activities or issues are obstructing the proper function and balance of the riparian area. In many cases, these activities hamper the growth of necessary riparian vegetation. Listed here are some of the common hindrances that can disrupt the equilibrium and keep river riparian areas out of balance. Common hindrances include farming, mowing, or spraying weeds or brush too close to banks, logging and related timber harvest activities adjacent to the creek, manicured or altered residential and park landscapes next to a creek, prolonged grazing concentrations in creek areas, excessive population of deer, exotic hoofstock, or feral hogs in creek areas, burning in riparian areas, removal of large deadwood and downed trees, artificial manipulation of banks, channels, or sediment, physical alteration of floodplains, excessive vehicle traffic in creek areas, excessive recreational activity or foot traffic in creek areas, excessive alluvial pumping or other withdrawals, low water dams, large reservoirs, poorly designed road crossings and bridges, The ease or difficulty of addressing each of these hindrances varies considerably. For example, it's relatively simple for a landowner to stop mowing vegetation close to the creek bank. It's a matter of recognizing the impacts and potential damage and making an intentional decision to stop or modify the practice to reduce impacts. Likewise, it is straightforward for a livestock rancher to alter grazing management to reduce or eliminate chronic livestock concentrations in creek areas. However, he or she must first become convinced that livestock concentrations in riparian areas are detrimental. Although straightforward, considerable effort and expense to implement needed changes in riparian grazing management may be required. Other practices are a much greater challenge to overcome. For example, excessive populations of free-ranging exotic wild ungulates such as axis deer are a severe problem on hundreds if not thousands of miles of riparian area in the Edwards Plateau. While many landowners and natural resource professionals acknowledge the problem, long-term solutions are exceedingly difficult to apply. Other hindering practices may require legislation and regulation and ongoing enforcement to overcome. An example of this is the tremendous riparian damage caused by unrestricted motor vehicle driving in public riverbeds. In 2003, Senate Bill 155 was passed by the Texas legislature, which restricted and regulated such driving. In the years since this legislation, many miles of riparian lands are restoring themselves naturally in the absence of vehicle traffic. Any practice that hinders natural processes will prevent or retard restoration of the riparian area. When such practices are altered or eliminated, riparian areas will tend to gradually fix themselves. Recreational driving in this riparian area has removed a large area of vegetation in the floodplain, so restricting vehicle driving will allow the area to heal. Still, other hindering practices are so difficult to overcome that they are not yet being seriously discussed. Examples included the thousands of low-head concrete dams that have been constructed in creeks, mostly on private land, and disrupt the natural movement of sediment that's needed downstream to build point bars and sinuosity. Further, erosion often occurs below these dams, causing other problems. Some landowners are considering removal of these structures. There are thousands of poorly designed crossings, culvert installations, and bridges, many of which are under the jurisdiction of county or municipal road and bridge departments or the Texas Department of Transportation. Restrictions in control of pumping of shallow alluvial aquifers may be another instance where legislative and regulatory solutions are warranted. Exploitation of alluvial aquifers for agricultural irrigation or other purposes is severely depleting the base flow of some rivers and creeks here in Texas. The photo here illustrates an extreme example of chronic livestock concentration hindering riparian recovery. A change in grazing management will be required to allow natural processes to restore vegetation. Excessive mowing near the creek hinders the development of necessary vegetation and prevents natural recovery. A change in mowing practices will allow plants to grow and will help restore proper function. Excessive recreation can hinder proper riparian function in parks and heavily used areas. By altering and managing access, riparian managers can promote a degree of restoration while still allowing recreational enjoyment. Some creekside landowners manicure areas to create a park-like appearance. Though a cleared, cleaned appearance may be favored, riparian outreach and education teaches those landowners the extreme value of preserving their dense riparian vegetation. In most cases, if the factors that are hindering riparian recovery are dealt with, the riparian area will begin to restore itself naturally. The natural regeneration of appropriate riparian vegetation is often the mechanism that allows this recovery to take place. Within nearly all medium-sized or larger creek systems, there is an adequate resource of desirable native riparian vegetation upstream. These intact or partially intact upstream plant communities provide a source of seed and plant material for downstream establishment. During runoff events that exceed bankfull discharge, where floodwaters spread out across the floodplain, these seeds and plant parts are carried downstream and deposited onto wet ground. Seeds that are dispersed in floodwater include cypress, buttonbush, sycamore, maple, elm, pecan, oaks, sedges, rushes, cutgrass, knotgrass, eastern gamagrass, water primrose, and many others. Other plant parts that detach and float downstream and root in a new location are called plant propagules. These can be a large clump of sedges or grass that gets washed out in a flood, or with the clump being broken up into many individual plants and floating to new locations. Or it can be the detachment of stems or stolons or runners of riparian plants such as water willow, watercress, and knotgrass, which will root from stem segments. Once established in a new location, these plants will make additional seed and rootstock to increase new plant establishment. Other plants have different modes of dispersal. The seeds of certain riparian plants are dispersed by the wind. Examples of wind-dispersed plants are bushy bluestem, baccharis, willow, cottonwood, cattail, goldenrod, and bricklebush. Other riparian plants are commonly spread by wild animals or livestock into new locations. Regardless of the specific method of plant dispersal, it is important to understand that the natural regeneration of riparian plants is an effective method of re-vegetation. The beauty of natural regeneration of riparian vegetation is that it takes place naturally and effectively without the high cost and intensity of artificial re-establishment. Normally, this natural process will establish an appropriate and desired diversity of native riparian species, including both early-stage colonizer species as well as the stronger stabilizer species. After a single high-flow event where fresh new seed is deposited, it is not uncommon to observe seedling densities of 50 to 100 plants per square foot. Furthermore, natural regeneration takes place progressively and repeatedly over time, with new seed and new species added. Natural regeneration usually takes place within a reasonable period, but it's closely tied to the timing and frequency of out-of-bank flow events, rainfall, and other climatic factors. Unfortunately, in some locations, regeneration of native plant species is hampered by the rapid establishment of exotic and sometimes invasive plant species. This is discussed in a separate section later in this manual. As with any natural process, there are times when desired vegetation does not establish according to our expected timeline. Patience is very critical, and for the riparian manager especially. There is little that can be done to speed up this process without high inputs and costs, and still there is no guarantee of success. In some special cases, it may be important to establish new vegetation as quickly as possible and not wait for natural regeneration to occur. Other times, the on-site and upstream source of native plant materials may be so impaired that natural regeneration will occur far too slowly or ineffectively. These circumstances may warrant the planting of riparian grasses, sedges, shrubs, and trees. The replanting of riparian vegetation on degraded or heavily disturbed sites should generally attempt to mimic the natural plant communities to the extent possible, if soil conditions permit. Project managers should search for nearby stream reaches that support intact, functioning native plant communities. These may serve as helpful benchmarks to guide in the selection of plant materials. In the future, ecological site descriptions, or ESDs, for riparian areas will help managers determine appropriate plant species to use. Ecological site descriptions have been developed for many upland soils in Texas and are compiled and published by the Natural Resource Conservation Service. However, ESDs for riparian areas have not yet been developed in Texas. At the present time, there are commercially available seed sources for only a few important riparian species. This shortage creates a challenge for establishing appropriate plant diversity. Commercially available seed for riparian species include switchgrass, eastern gamagrass, bushy bluestem, western wheatgrass, Canada wild rye, and Virginia wild rye. In addition to establishment by seed, some growers now offer rootstock of riparian plants for sale. If growers are contracted 1 to 2 years ahead of time, there are some that are willing to custom grow riparian plants on a contract basis. Perhaps the most effective means of artificially reestablishing riparian plant communities is to locate nearby intact riparian areas and seek permission to dig and transplant fresh rootstock. Although the process is labor-intensive, results have been quite promising. Riparian species that have been successfully transplanted include emery sedge, sawgrass, switchgrass, eastern gamagrass, knotgrass, spike rush, goldenrod, and scouring rush. Many other species have not yet been tried but still hold much promise. Plants are ideally dug in winter or early spring and immediately transplanted to a similar location, paying special attention to moisture requirements and depth to the water table. For the establishment of riparian woody plants, nurseries offer bare root or containerized plants of bald cypress, sycamore, roughleaf dogwood, bur oak, chinkapin oak, pecan, cedar elm, and many other native riparian trees. The fastest way to get large numbers of woody plants to establish is to use stem cuttings and pole plants of species that are known to root from dormant stems. All species of willow and cottonwood are readily rooted from dormant branches, twigs, or poles planted in late winter. The butt of the stem must be planted deep enough to stay in contact with moist soil during the first few years. Other woody plants that are known to root from dormant stems include buttonbush, sycamore, American elder, and some species of baccharis. For new plantings, protection from livestock and wildlife grazing or browsing is very important and often will be the primary factor in success or failure. Today's lesson introduced the basics for riparian management. Topics discussed include intensity of riparian management, riparian function as the cornerstone, maintaining equilibrium, identifying, addressing, and removing hindrances, natural regeneration, and artificial revegetation. In our next lesson, we'll discuss management guidelines for different land use types.